In this video, I'll be taking you through the design of a simple product, of simple sheet metal product, and how to convert the concept sketch into a sheet metal design which can be manufactured. So here is the context. So we have a mobile which is having a length of 165 mm and a breadth of 77 mm. This shows the CAD model of that mobile, and that has to be rested on top of a table which is shown over here. So we need to design a very simple sheet metal component which will allow the mobile to be rested as shown with an angle of 17.8 degrees to the vertical. So here is a sketch, a rough sketch based on which we can design. So you want a part like this which has these bends, one over here, this one over here, and at the bottom it has the largest surface which is resting on the table. And here are the specifications given for that drawing. So using these specifications, we will start designing in the sheet metal workspace in Fusion 360. So first, the thickness is 2 mm. So this resting surface should have a length of 70 mm. This total leg length should be 95 mm. And this total leg length should be 90 mm. And this angle is 45 degree from this face to this face. This is 62.8 degrees. And it should have a gap of 20 mm from the table. Here is the input data available. A mobile phone with the set dimensions, which is inclined at 17.8 degrees to the vertical, and this is the resting surface. So this data will be available for download, so you can download it and try testing out the design. Now the first step which we need to do is create a flange, and first we will create the resting flange. So we will go to sketch and we will select the sketching surface as the resting surface of the mobile, which is this one. And let us hide this component and create a rectangle like this. Now in the drawing, it is mentioned that this dimensions should be 70. So let's make this 70. Drag it down. So after making the rectangle, I gave a dimension of 70 using the dimension tool, which is available here, sketch dimension, using this dimension tool, and also the width dimension. Select sketch dimension width. Let's keep it at 95. And let's finish the sketch. So this is the base sketch, and we'll create a flange from this. Go to flange, select this complete closed area and press OK. So this will create a flange. So here is the sheet metal body which has been created, and this will create a flange. Now the next thing is to create a flange which is 90 degrees to this, which is supporting the bottom edge of the mobile. So for that we need to again go to flange, select this edge, select this edge and pull it. Let's say keep it at 10 mm. Let's say keep it at 15 mm and press OK. You can see that this edge and this surface is not aligning. So we can modify the sketch over here, which was the original sketch created. So if you are making this coincide with this line, so this bottom line, if you are making coincide with the bottom line on the mobile, then we can create an accurate design. So for that we need to go into constraints, collinear, select this line and select the reference line from the mobile model, and it will become collinear. So now this is basically going through it. So for that we need to change the settings on the flange. So here it is inside, bend position is inside. So clicking on the flange, double clicking on the flange, it will open up the options. Here bend position is inside. If you make it outside, then we will not have this problem. It will be correctly aligning with the bottom surface of the mobile. and press OK. Now let's bring in the reference table on which it will be rested. So create another flange, select flange and select this edge, and drag the arrow out. Make sure the angle is 45. So if it is showing this side, then flip it, or we can give angle which is 180 minus 45. So that way it will bend in this direction. So this angle will be 45 because it is taking angle at 180 minus x. So the leg length will be 95 and press OK. Leg length is 95, pressing OK. And then the bottommost flange which is resting on the table, select this edge for the flange, select flange, select this edge, bottommost edge, and then so drag it out. We'll see that at default is 90 degrees, but we want it to align with the top surface of the table. So for that, let us rotate this, and that is a certain angle which we need to enter. Now that angle can be calculated based on whatever data we are having. Going back to the reference sketch, 62.8 is this angle. So we need to input 180 minus 62.8. Coming back to the workspace, let's enter 180 minus 62.8. And let's take this side view so we'll get to know. So that is a gap over here, and let's give it a height of 90 mm. So now there is a gap over here, which basically means that the leg lengths which we have entered are incorrect. So we can modify it. We can always modify it to match the surface. So for that, let's go to this value, and or we can do another thing. We can just go to this flange and make it outside. If you make it outside, you can see that it is aligning with the surface. So instead of inside, if you make it outside, it will align to the surface, and press OK. So actually it is not aligning, it is going inside. So probably we need to tweak it a bit. So we can just change this value. Let's say keep it at 94. Then it will come out. So some tweaking has to be done to match the surfaces. Or if you want to have a perfect parametric design, then we need to calculate the outside setback and then calculate the exact values which we need to put into these flange dialog boxes. For now, this is just to demonstrate how to create a basic product design of sheet metal using the sheet metal workspace for Fusion 360. Now, if we want to create a flat pattern of the sheet metal part, let us hide the other components, the mobile phone reference and the table reference. So we need to create a flat pattern. For that, we need to go to create flat pattern, and the reference face, the stationary face, which will not be unfolded, has to be selected as this one, which is the base face. Select this as the base face and press OK. So now the flat pattern is created and the bending lines are also present on it. And from this, as we had earlier seen, we can create the drawing easily. We can give tolerance values, basic tolerance values, and for prototyping, this should be enough for manufacturing.